All right, now water is special, and that is why I just have this isolated. Remember, and I kind of cut this off, but it is covalent. And water is special because it has a unique structure, and we're going to follow the same steps, but I'm just going to explain one additional thing about water. So to start, we've got to do our steps. And, after a while, you'll be able to do this very quickly. I'm just step by stepping it because we want to make sure everybody understands. So there's 2 hydrogens, and each of them has 1 valence electron. There's 1 oxygen, and each of them has 6. So that means there are 8 valence electrons. Second step, octet electrons. Hydrogen, there are 2 of them. Oxygen, there's 1. Each hydrogen requires 2 electrons to have octet. Each oxygen requires 8. So that means there are 12 octet electrons. Step 3, octet electrons minus valence electrons equals bonding electrons. In this case, we have octet electrons equal to 12 minus valence electrons equal to 8, which is equal to 4. So that's 4 bonding electrons. Step 4, bonding electrons divided by 2 is equal to number of bonds. So our bonding electrons we said are 4. Divide that by 2, and that equals 2 bonds, which makes sense if you look at. So then step 5, so step number 5 is to create or draw the basic structure. And like I said, usually the central atom is listed first, but hydrogen can never be a central atom because of the fact that it only requires 2 electrons. And, it could be in a line with one other thing, but a central atom is implying that there are things around it. So oxygen has to be the central atom. And our H's go on either side. Step 6 is we take our valence electrons minus our bonding electrons, and that is equal to our non-bonding electrons. So valence electrons are 8, bonding electrons are 4, and that means we have 4 non-bonding electrons. So then we will go up here and we will make sure that everything has octet. So obviously the hydrogen has octet because it only needs 2. So then that also means that each of these is 2. So right now the oxygen has 4, and 5, 6, 7, 8. And that covers our 4 non-bonding electrons. Now, in actuality, and this is something you should know, what will happen is the oxygen will actually have 4 of these electrons.
Brian Ambrose, call 2001. Brian Ambrose, 2001, please.
At the top, and those electrons repel the positives, and therefore it has what we call a bent shape. Kind of looks like this in a molecule form. And so this is truly what water looks like. And I'm not going to mark you off for putting the electrons here for right now because we're not going there yet to explain the shapes. So That is the molecular structure for water.